Everyone, is the microphone working? Yeah, it's brilliant. So, my name is Marek Isalski. I work for a small company, Faelix Limited. I'm going to talk to you about keeping your rack cool with one IP root rule. And I understand, we've had that quite annoying fire alarm. Well done, everyone, for dealing with it. So I've been asked, can we try and keep this a bit more to time? So there's what I'm talking about at the end. Any questions? Not so fast. What I'm going to talk to you is a very brief introduction about what we do, our experience using MikroTik devices at the provider edge, and then the sort of main part, the second half of the talk, is going to be building firewalls that have no filter rules. No filter rules? No filter rules. So, MikroTik routers at the provider edge. Our network, we've got stuff in data centers in Manchester and Geneva, two Equinix facilities up in Geneva and one down in, up in Manchester and one other provider down in Geneva. We are a mostly hosting ISP. We've got servers, basically. Our focus is on social stuff, security in the environment. Our offices are in Manchester, but half our kit's in Geneva, partly because there's some really excellent energy efficiency we could do down there, and that fit with our sort of social issues and environmental customers. We are multi-homed, we're multi-site, we run our own autonomous system, number 41495. Now, just to get an idea of who I'm talking to, who in the room is what we would call an eyeballs network? That is, most of the things connected to your network are people who are downloading stuff. Just quick show of hands. Who are eyeballs networks here? Okay, and who are content providers? So servers are chucking out traffic. Wow, okay, there's not many. I'm going to try and make this talk cover both, but mainly you two are going to be interested in this. And who in the room is a multi-homed network? That means you've got multiple transit providers. Versus single-homed? I guess that'll be everybody else. For the everybody else in the room, multi-homed means you take an internet connection from more than one upstream provider. Your routers at your network edge talk to their network edge with usually BGP, and maybe they tell you a default route, which is how to get to the rest of the internet. Or maybe they send you the entire internet's routing table, the so-called default free zone, which is a lot of routes. And if you actually pipe that into router OS, you get that in your routing list because it can't cope. It's wise to have at least a couple of gig of RAM in whatever device you connect this to, otherwise it is just going to keel over quite quickly. In 2015, we were looking at upgrading our edge of our network, and one of the options was to stick in some MikroTik routers. We'd been running Quagga and Bird on Linux boxes on just bog standard x86 servers up till then. One of the things that attracted us to MikroTik was the energy efficiency of some of the CCR devices. Really quite like the fact that both with the sort of Linux platform that we've been coming from and potentially with the MikroTik solution, there's no GCHQ or NSA baked inside. Maybe can't quite say the same about Cisco or Juniper at the moment. So yeah, can we use router OS? Are we going to be confident enough to router OS? And maybe we're going to run Bird just in case there are some problems. And one of the reasons we chose for running more than one platform was when we actually first trialed Bird, we turned up a Cogent transit feed and it segfaulted. Now that might be a legitimate response to being faced with being given Cogent transit, but had we not also been running Quagga, literally we would have vanished from the internet. Our announcements would no longer have been going out. So we were thinking, let's have a backup plan. Let's keep our Bird boxes going just in case, because we don't know, is this going to cope? Are we going to be able to debug this? What's support going to be like? It was a little bit of a plunge into the unknown once you actually start putting real live traffic over it. There's only so much you can lab up. Over a year on, I'm happy to say our experience has been pretty good. There's been some weird behavior occasionally. These two graphs I'm showing are of two of our edge routers' CPU usage. Each color is a different core within the CCR. And you'll notice there's a couple of periods where like one core is just being hammered constantly rather than it being spread out. And the sort of sudden changes you see are actually when we've upgraded a router OS version and rebooted the device. And so there are some differences between each version as you run them. We were bitten by a leap second bug last year. One of our two routers actually crashed hard and would not reboot even with a watchdog. It required a power cycle. We've also found an interesting one where if you change the physical interface or the VLAN ID of a VLAN interface, potentially it just reboots. It's a crash. So with this and a little bit of looking around the forum, you get an idea that there are a couple of edge cases that aren't perfect, but once you learn to avoid those, potentially you can actually use a MikroTik right at the edge of your network. When we've contacted support, they've been pretty quick, and anecdotally it's been at least as good as dealing with the big names about whom we shall not speak here. For debugging, I've already shown you that if you actually look at the IP root list in WebVig or in Winbox, you just get, sorry, there's too many results here, so you will have to get friendly with the router OS command line to start digging around and seeing what are all of my AS paths and what routes am I receiving and what is the best route for this. Overall, though, it's been pretty good. For about £700 and 70 watts of energy, you can route 10 gig or more of traffic. BGP feels pretty familiar after our years of experience running Quagga. There's obviously consultants and trainers out there, and over the time we've been running this at the edge of our network, we've been confident enough with the Router OS platform that basically MikroTik are now our go-to choice for if we need some wireless gear, if we need a customer router or whatever else. Vendor interoperability has been pretty good too. They're not so good. The watchdog wasn't great enough for when we had the crash due to NTP. If there was some sort of out-of-band way of rebooting a router, a bit like you have it on servers, that would be wonderful, but otherwise connect this to some sort of managed UPS or switched PDU that you can power cycle in the event of a true emergency. BGP is slow to converge and get the routes into the routing table when you've got 2 million routes or more. It's a bit better on x86. Routing filters don't always work first time with BGP. This is a sort of known bug if you dig around the forum, so you end up having to sort of enable them or disable them and move them around. If you ever touch the CRS stuff for switching, the VLAN setup is basically like trying to configure the merchant silicon as a sort of really raw thing. It's nowhere near as friendly as maybe your pro curves of this world where you can actually get a nice, quick, easy, what port gets what, tagged where, done. And of course, Router OS 7 is sold as the solution to all of these little foibles, but, well, when? Tips for if you actually want to do MikroTik at the provider edge, cloud-hosted router and other hardware is economical, get a lab. If you are running Router OS at the edge, because sometimes you will find a bug that only comes up a couple of weeks after you actually get running it, maybe leapfrog Router OS versions on different routers, so you're not common on one version and both your routers have the same problem at the same time. We wanted to eliminate layer 2 from as much of our network as possible. We don't want any layer 2 loops. We don't want to rely on spanning tree. Working at layer 3 made this affordable and this dream come true. If you're doing configuration management, check these things out. Oxidized is a brilliant piece of open source software which will suck in all of your router's configs, store them in Git repositories. You can see the previous versions. It's open source, just do it. Get all your logs in one place with syslog. Check out SNMP, Graphite, Grafana. Get some visibility of what your network's doing. It's cool dashboards for your boss as well. And if you are starting to route on the public internet, look at BCP38, Manners, the routing manifesto, publish an abuse contact. Let's be excellent to each other so we can deal with bad traffic and other issues that arise. A couple of quick plugs for people running a network like us. Get to UK North, come to Net Manchester. These are for packet pushers of the UK. There's beer at both of these, funnily enough. You could actually say it's peer-to-peer networking. So, right, this is the bigger part of the talk. Firewalling without any filter rules. You what, mate? I'll get there. First of all, I'm going to talk about what we're trying to filter. If you've ever connected a device to the internet, you will start to see SSH attacks, people trying to get into your SMTP server and see if it's open. Oh my God, this is a VoIP device. Can we dial abroad? If you've got WordPress or Drupal or any sort of websites, you're going to start seeing people trying to create user accounts, log in, post spam, scan for vulnerabilities if you've got phpMyAdmin installed. If you're providing VPNs and you've got router OS there, you're going to see all sorts of crap in their logs as well. This is what we're trying to filter out. We're trying to get rid of all of this stuff that is just burning CPU cycles within your network. That's what I mean by keeping a rack cool. So your network will get scanned. Maybe you've closed down everything. Maybe you've forgotten something. Is your management network completely isolated? Do you have to VPN in to do everything? And then your customers are going to do something you don't expect, like have SNMP enabled on their CPE, and suddenly you're spewing out megabits of DDoS amplification. And software has bugs, so we're always patching them. So we're trying to do a really broad brush, trying to clean up the big piles of shit on the internet. Here's a very, very simple, small graph of one of our customers who found their website being hammered by about 60,000 different Chinese and other IP addresses. Some virus was just hammering it with posts to the front page. It's sort of tailed off over time over the last year, but basically this is what it did to that poor server's CPU. It was a load average of hundreds, and it keeled over. Again, we're trying to block out some of that because security's hard. So we were going to start with low-hanging fruit, the really simple things. Let's get rid of 90% of the dross hitting our network. And then we can focus on that 10% that's left, and then maybe go through that and start cleaning out that rubbish. So to do that, you're going to need some logs, you're going to need some data, because without visibility of what's going on, this is basically what your network and you driving it is like, okay? So get your logs into one place. Once you've got your logs into one place, now let's consider something trying to attack your network. It's a really stupid bot that's trying to take down, I don't know, a web server, say. Install this bit of software, fail to ban. It'll look at your web server's log files. It'll go, that's some nasty traffic, and it'll build a wall. And dead quickly, you've eliminated a whole load of dross hitting that one machine. Because they fail to ban follows a log file. It's great for blocking SSH brute forces, but you can also put some rules in for blocking your pretty standard web attacks as well. There are some great examples for how to use fail to ban to block people brute force SSHing into your router OS devices. You will probably find examples that use IP firewall filter rules and will add a new rule to drop traffic. If you can find an example that uses an address list, that'll be better. You'll get better performance out of it, and I'll come on to why in a moment. This is quick, cheap, easy. You can roll your own rules very easily to block the kinds of things that you are hosting, or indeed the kinds of things in your network that you're trying to protect as a broad brush. Attackers do move on pretty quickly, and the downside to that is they may move quite quickly onto something else within your network. So is there a way we can literally kick them out of the entire network? That's what I mean by blocking at the provider edge. So we took our scenario earlier where fail to ban has blocked them and put some IP tables or whatever on this device. And we squirt a message into, we use a queuing system called AMQP, roll your own as suits. And that feeds into a little process and database we have called the slurry. This is basically an IP reputation database. It's gone, something's attacked this server from this address. Let's just make a note of that. And over time, that reputation database fills up with more and more information about the things that are hitting our network, and maybe even the whole ISPs who are commonly hitting our network. From that, the slurry will actually send out a message to AMQP, and that fans out to a bunch of processors called the spreaders, the MUX spreaders. Each one of those talks to one of our edge routers, which via RouterOS's API will block them at the network edge. Literally, at that point, no traffic from that IP address is coming anywhere near any of what we look after. The downside to blocking at the provider edge is there are lots of flows going through your edge of your network. There's lots of packets per second. There are lots of addresses potentially attacking. So don't use an IP firewall filter where you add one rule each time, because you end up scanning down that list, and scanning down that list when you've got 10,000 of them is going to make your router go very slowly. Use an IP firewall address list instead. It's a hash table. You only need one rule. It's dead quick. Like I say, we used AMQP with RabbitMQ to get this information between all of our machines and all of our data centers. If you're operating something smaller, choose something that's appropriate. You will get false positives, though, and this is what we're going to try and evolve now with the next step of our solution. So along comes somebody trying to access their webmail, and they have locked themselves out because they've typed their password in wrong 5 times or whatever your fail to ban threshold is, and now they can't get in. And the result of that is their browser says a message which very quickly turns into a support call for you. What's going on? The server's down. The server isn't down. You've just locked yourself out. So how can we communicate to the user, you've screwed up somewhere? Why don't we take all of the traffic from their address and DNAT it to a virtual machine that's specifically within our network to pop up one message that says, you've been blacklisted. So literally, for as long as that blacklist is in place, they just get this, no matter what URL they hit that's hosted within our network. It's not going to work for SSL, but for the vast majority of people who are going to lock themselves out, it's going to deflect a lot of support calls. So now we've sort of started to head away from having filter rules. We're now actually just natting the traffic to one bad machine, machine within our network to grab all of this bad traffic. And if I go back to the earlier slide from Jurassic Park, the name for this machine within our network is the shit pit. This is where we dump all of the shit we don't want. The problem is, if we're now doing that, we're now tracking connections. And if we're tracking connections, this is going to have a detrimental effect upon your router's memory. Because as I said in an earlier slide, there are lots of flows, loads of flows going through your network, and you're now tracking each one of them. But we could use a mangle rule to only track the bad traffic. No. We want to build something we can understand, where if we try and touch it, we actually know what we're messing around with. The other problem that we're going to have is we're a multi-homed network, so traffic could come in and out of our network via any of these routers. It could come in here and go out there or there or there, which means when bad traffic comes in and goes to that VM, because it's been natted by that router there, we've got to send the traffic out via that same router, so it gets the NAT removed on the way out. Because otherwise, if that VM sends it there, that router's going to have no idea what it is. It's not going to work. The connection's just going to die there and then. So contract, NAT, this isn't going to work for our kind of solution here. Maybe we could share the contract data between all of our routers. That would be really, really cool. It would work really nicely for some sort of high availability default gateways or whatever. But actually, we're still then going to have to track all of these flows going through our edge of our network. Surely there's got to be some easier way. Are we there yet? Well, the good news is we're now at the stage where I can actually sort of explain that very, very first slide. This is it. This is the whole solution. So at the beginning, we go and create a new routing table. We say literally everything that has been marked with a certain firewall mark should go to this gateway. That gateway is our VM, the shitpit VM, which is going to gather all of this traffic and NAT it locally and serve up that sorry you've been blocked message. We have to have an IP rule. This is the one that the title of my talk alludes to. And we need to have one thing in the firewall, and it is a mangle rule to say anything that is within that, that address list, chuck it in such a fashion that it will go towards this VM. And then for every bit of abusive traffic that hits our network, all we need to do is get an address added to our firewall address list. And we can have a timeout for that as long as we want, and in our case, the slurry process actually increases the amount of time the longer the attack goes on. So now we're getting our nasty traffic landing on this honeypot, and our catgif blog is continuing to serve traffic quite happily. But what we can now do is we can sort of evolve our idea a little further. We can actually look at the bad traffic that's hitting our shit pit machine and have a look, is this attack still going on? And if so, hey, let's just keep them blocked. And for the vast majority of times, they notice that they've been blocked and they back off very quickly because these bots, they don't want to waste time. But occasionally you'll find many days-long attacks. This is, I think, the last 90 days of traffic to our junk box. And some of those attacks are going on for literally a week or more. We're actually starting to use what hits that box to be able to make more rules, which we can then give to our customers going, hey, people are also scanning for this and this and this. Why not use that in your alerting so that when you build your firewall with fail to ban, you're responding quicker, but also you're sending us the information quicker. And now for a bit of extra credit, well, why not get the VIPs, the people within your customer base that have static addresses so that they don't get blocked so much? Maybe look at the website badips.com. They have an API where you can submit traffic or submit abusive IP addresses, but also scrape abusive IP addresses out. So you could actually preload your edge blocking with this. Maybe you want to use DNS RBLs for, hey, these people are spammers or are hosting phishing websites or similar. So you can actually start getting things blocked so your customers aren't actually reaching those kind of phishing websites. Maybe you are interested in being DDoSed and you want to install something like FastNetMon, which will take NetFlow information from your network edge and tell you when there's a load of traffic hitting one of your IPs, and then start automatically blocking off the IP addresses so you're not actually taking it all the way into your network, which in the case of wireless ISPs could be quite expensive in terms of your capacity. Maybe you want to run Snort at the edge of your network, take a copy of the traffic, analyze it with an intrusion prevention system, and again, populate your block list and react quickly. I've mentioned some of these bits of software. I've got this on a slide just so that people reading the slides will be able to refer back to it. Fail to ban, I've mentioned. FastNetMon is a great way of doing DDoS detection. Do you want to check you're being port scanned, port sentry? You can easily link something like that in here. If you're running lots of web servers, get something like mod security and the very, very recently released new OWASP rules, which will block an awful lot of nasty traffic from hitting web applications. I've mentioned Snort. It's a brilliant intrusion detection system. Again, you'll have to find rules that match the kind of bad traffic that's hitting you. But as you get rid of 90% of the rubbish hitting your network, you can actually start honing it down and looking at the next bad bits and pieces. So, in conclusion, that's what I'm talking about. It's those 4 little things that may actually help deflect an awful lot of rubbish from hitting the edge of your network and let you concentrate on some of the more interesting things and fun things in life, like sitting and chilling out by a lake. Thanks very much for your time. Any questions? No questions? No? Well, I'll hand over to the next person then. Thank you very much.